Welcome to Class 8, Mathematics Chapter Power Play. Today we will learn how to calculate with scientific notation, tackling numbers so huge they would fill an entire page with zeros. From clothes to bees to bacteria to time, let us dive in. We break down questions step by step to help you understand better. Hit like and subscribe to support the channel. A quick refresher. Scientific notation writes any number as something between 1 and 10 times the power of 10. The coefficient x must be at least 1 and less than 10. So 50,000 becomes 5 times 10 to the 4. Here is the multiplication rule. A times 10 to the m times b times 10 to the n. The front parts multiply. A times b gives us the new coefficient. And the exponents add up. 10 to the m plus n. For example, 3 times 10 to the 5 times t times 10 to the 3 equals 6 times 10 to the 3 equals 6 times 10 to the 8. Keep this rule handy, we will use it a lot today. Part 1. Each person has 30 pieces of clothing. But how many people are in the world? From our textbook, the world population is about 8.2 billion. That is 8.2 times 10 to the 9. So we multiply 8.2 times 10 to the 9 times 30. Let us break 30 into scientific notation too. 30 is 3 times 10 to the 1. Now rearrange 8.2 times 3 times 10 to the 9 plus 1. Multiply the coefficients. 8.2 times 3 equals 24.6. Add the exponents. 9 plus 1 equals 10. But wait, 24.6 is not between 1 and 10. We need to adjust. 24.6 equals 2.46 times 10 to the 1. So our final answer becomes 2.46 times 10 to the 11. That is about 246 billion pieces of clothing. Part 2. 100 million bee colonies, each with about 50,000 bees. First, what does 100 million look like? Million means 10 to the 6. So 100 million is 100 times 10 to the 6. But 100 is 10 squared, so 100 million equals 10 to the 8. And 50,000? That is 5 times 10 to the 4. Now multiply 10 to the 8 times 5 times 10 to the 4. The coefficients give us 5 and the exponents add up. 8 plus 4 equals 12. So 5 times 10 to the 12. 5 trillion honeybees. And this time, 5 is between 1 and 10, so we are already in proper scientific notation. Part 3. This number will blow your mind. Each human body has about 38 trillion bacterial cells, and there are 8.2 billion humans. First, what is 38 trillion in scientific notation? Trillion means 10 to the 12, so 38 trillion is 38 times 10 to the 12. Now multiply 38 times 10 to the 12 times 8.2 times 10 to the 9. Rearrange 38 times 8.2 times 10 to the 12 plus 9. Let us compute 38 times 8.2. 38 times 8 is 304. 38 times 0.2 is 7.6. Add them. 304 plus 7.6 equals 311.6. So we get 311.6 times 10 to the 21. But 311.6 is way bigger than 10. We need to convert it. 311.6 equals 3.116 times 10 to the 2. So our answer becomes 3.116 times 10 to the 23. Rounding, approximately 3.1 times 10 to the 23 bacterial cells. That is more than the stars in the observable universe. Part 4 is different. We need to make our own assumptions. How much time do we spend eating each day? Let us estimate about 1 hour per day. That is just eating, not cooking. A lifetime? Roughly 80 years. And there are 365 days in a year. But we need seconds. 1 hour equals 60 minutes times 60 seconds. That is 3,600 seconds. Now multiply 3,600 times 365 times 80. 3,600 times 365 equals 1,314,000. Then 1,314,000 times 80 equals 105,120,000. In scientific notation, move the decimal 8 places. 1.0512 times 10 to the 8. So roughly 1.05 times 10 to the 8 seconds of eating in a lifetime. That is about 3.3 years. Some estimates use 6 hours per day for all food-related activities, giving about 6.3 times 10 to the 8 seconds. Here is our reusable method for multiplying huge numbers. First, convert everything to scientific notation. Second, multiply the coefficients, the front parts. Third, add the exponents, the powers of 10. And fourth, the step everyone forgets, check if your coefficient is still between 1 and 10. If it is 10 or bigger, shift the decimal left and add 1 to the exponent. That adjustment step showed up in parts 1 and 3 today. And here are all 4 answers. From clothes to bees to bacteria, you just calculated numbers that stretch into the hundreds of sextillions. That is the power of scientific notation. It turns impossible numbers into manageable ones. Every time you see a huge number in the news or in science, you now know exactly how to work with it. Keep learning and keep growing. See you in the next question.